Hello everyone. So this is Mallikarjun, Department of IEEE from IARE, that is Institute of Aeronautical Engineering. So today we are going to discuss about different types of armature windings in case of a DC machine. So what are the different types of winding that you can adopt for a particular DC machine? Either it may be a generator or it may be a motor. So in the previous class, we have discussed about what is the construction of a DC generator. So what are the different constructional parts of it and also different things. So in this, we are discussing about the different types of armature winding. So basic types of armature winding that you are going to keep in the inner periphery of a DC machine. So what are the different types, and we are going to discuss about those things. And these are different types of COs. Already we have discussed about these things. So our main topic is regarding what armature winding. So before going to discuss about the different types of armature windings, I would like to explain about what is an armature winding in a brief view. The first thing is, an armature winding is a set of insulated copper coils that are wound around the slots of an armature peripheral surface. That is, suppose this is nothing but my particular construction of a particular DC machine, and let me say that this is nothing but my armature. So I will use certain copper wires. Which are wound around the slots. There are certain slots which are present in the armature here. So in the slot, I will house certain winding in the inner periphery of that particular thing. So that winding which is placed or wounded in the inner periphery or slots of the armature peripheral surface is called as what? Armature winding. Is called as what? Armature winding. And the main purpose of having an armature winding is nothing but it carries some amount of current in it. So the current may be a direct current or else it may be an alternating current. So the main purpose of carrying the current is nothing but to generate the EMF. What is EMF? Electromotive force. The main theme of having an concept of EMF here is nothing but we are going to discuss about the different types of windings in case of a DC generator here. The output what I need for a particular generator is nothing but what? EMF. So the armature winding is going to play a key role in developing an EMF, that is nothing but a voltage. And not only that, it is also used to create a torque or force by carrying some amount of current across a magnetic field. Suppose there is a magnetic field here and I am keeping my coil like this. If I pass some amount of current through this particular coil in case of a magnetic field, it will develop some amount of force or else it will develop some amount of torque. This is nothing but what it is considered as a working principle of an electric motor, that is Lorentz force law. That is nothing but what? Lorentz force law. And the armature can conduct AC, purely AC, even on direct current machines using the commutator. So there is a particular component called commutator which reverses the current direction every oftenly. So by already the armature conducts an AC, but it can be used for DC by connecting a commutator to it. Or else you can go with the electronic commutation method also. Now we will discuss about the different types of armature windings of a DC machine. So in case of an armature winding, there are different types of windings like open type and closed type. And in case of an open type, we will have a drum type. And this drum type armature windings are used in this particular DC machine. Either it may be a generator or it may be a motor. So that is the first point what we have discussed here. In DC machines, the drum type armature windings are used. And what is the main specialty of having a drum type winding is the armature conductors are placed in the slots around the surface of a cylindrical or drum shaped armature core. Suppose let me say that this is the shape of a armature core and the winding is placed, armature conductors which are carrying some amount of current are placed in such a way that it is forming the shape of a cylinder in it, or else it is forming a drum shaped armature core. And the connection is nothing but these coils are connected in series through commutator segments such as to collect the EMFs, and whatever the EMF we are getting in the form of the output are added in order to get the total amount of EMF that is induced from that particular machine. Suppose if it is a DC generator, the armature coils are connected in series with the commutator segments. So what is the main purpose of armature? It conducts only AC. And why I am connecting this particular commutator? It inverts the value and it will go through that and it will collect some amount of EMF at the end, and all those EMFs are added together in order to get the total amount of EMF that is induced or generated from that particular machine. And you can see the structure representation of a DC machine here, how the coil, armature coil has been placed in this machine. You can see here, this is nothing but the winding. This is nothing but the winding, and this is nothing but the core where I am placing my winding in it. Core where I am, this is nothing but the shaft which is used for rotating in nature, and this is nothing but a commutator. So there is an armature core, and in case of an armature core, within the slots, in case of an armature core, I am placing some amount of winding where that is called as a armature coil, and this combination is connected to a commutator, and finally it is connected to a shaft. And finally it is connected to what? It is connected to a shaft. So this is regarding what? This is regarding what is the main use of having a drum type armature windings. Now we will come across the different types of winding in case of a DC machine. The first and foremost winding is nothing but a wave winding, and the second one is nothing but a lap winding. First one is what? Wave winding. Second one is lap winding. And the wave winding has been further divided into two types. The first one is progressive and the second one is retrogressive. So we will discuss about each and every type of winding in case of wave with respect to a figure, that is how the retrogressive winding structure will be, how the progressive winding structure will be. Coming to the next type of winding is nothing but what? Lap winding. So there are different types of lap winding. One is considered as a simplex winding and the other one is duplex winding, or else we can call it as a multiplex winding, or else we can call it as what? Multiplex winding. That is, what is simplex winding, what is duplex winding, how it is structurally represented as, what is lap winding. We will discuss about each and every type of windings in case of a DC machines in detail now. So coming to our first type of winding in case of a DC machine, that is wave winding. Wave winding. In case of a wave winding, the armature coils are connected in series through the commutator segments in such a way that armature winding is divided into two parallel paths irrespective of number of poles. So this is the general definition of a wave winding. That is how we need to wound a winding in case of a armature plots, whether it depends upon the number of poles or else it is irrespective of the number of poles. Suppose I have an example where there are number of poles in that particular machine is 4, number of parallel paths is nothing but 2, and the flux given is so and so, so and so. Now, for the given data, I need to design the wave winding structure for a given data. So the number of poles is given as 4. So when you are drawing the wave winding, or when we want to represent the wave winding, it doesn't depends upon the number of poles of that particular machine. Irrespective of the number of poles, wave winding has been divided, and always in case of a wave winding, the number of armature parallel paths is always equal to what? Always it is equal to 2. So it does not depend upon the number of poles or the flux of that particular machine, or else whatever it may be the given in that particular machine. Always if it is a wave winding, the number of parallel paths of that particular machine is always equal to how much? The value of A is 2. What is A? Number of parallel paths. Number of parallel paths. And you can see the representation of the wave winding in case of the given figure here, where it consists of two coils, where the two coils are connected to what? A commutator segment, as we have seen in the previous diagram here. So the coils are present inside the coil, and from the coils it should move to the commutator. The same representation has been done here. So it consists of two coils, where it has been named as coil 1 and also coil 2, where coil 1 has north pole and south pole, and coil 2 is represented by north pole and south pole. And see, both the coils are connected to a base structure called what? Commutator. Base structure called what? Commutator. And you can see the representation. Always the number of parallel paths which are maintained in case of a wave winding is nothing but what? It should be 2. It should be irrespective of the number of poles of the machine. Whatever it may be the number of poles of machine, it may be 2, it may be 4, it may be 6, or it may be 8. Always the number of parallel paths in case of a wave winding is represented by A equal to 2. A equal to 2. Coming to the explanation. So how this can be represented and how it can be explained, I have taken a simple example here. I have taken a conductor which is represented by a Z. Now I have divided the conductor into two equal halves, where the conductor has been divided into Z by 2 and also Z by 2. The same thing is represented in this particular figure here. I have taken a single conductor and I have divided, but particular according to the this particular wave winding, always A should be equal to the number of parallel should be equal to only 2. So I have considered as 2 parallel paths here, where in case of a first parallel path there are Z by 2 number of conductors, and in case of a second parallel path there are Z by 2 number of conductors. In the similar fashions, the current will also gets divided into the parallel path. Suppose the total current which is flowing in this particular parallel path is IA. The current flowing to the top conductor will be equal to IA by 2, and the current flowing in the bottom conductors will be equal to what? IA by 2. IA by 2. So what is the reason why I have only divided this conductor into only 2 paths? Because according to the representation of a wave winding, always the number of parallel paths should be equal to 2. If the given conductor is Z, it is divided into 2 equal parallel paths. One is nothing but Z by 2, other is nothing but Z by 2, and the current flowing through this parallel paths will also gets divided. And the current flowing through this parallel paths is also gets divided. And in case of a wave winding, how the EMF is collected? So what is our final option is nothing but whatever it may be the type of winding I have constructed in case of that particular machine, either it may be a wave winding or it may be a lap winding. The ultimate aim is to generate some amount of EMF. Generate some amount of EMF. So whatever it may be the EMF generated in this particular wave winding machine, the generated EMF will be always equal to the EMF across the parallel path. So whatever the EMF which is generated across this parallel path, it will be equal to the total EMF generated in that particular machine. Total EMF generated in that particular machine. So this is how I am explaining the concept of a wave winding with respect to the number of parallel paths, where always the number of parallel paths in case of this particular machine should be equal to 2, irrespective of number of poles. Irrespective of what? Irrespective of number of poles. Now coming to the types of wave winding. So already we have discussed in the previous slide there are 2 types of wave windings. One is progressive winding, another one is retrogressive winding. So how can we define this progressive winding and how the structure is represented? Whether we need to move in a forward direction or else we need to go in a backward direction. We can express the definitions of it and the structure representation of this progressive winding here. So progressive winding, the definition is the coil is wound in one direction, that is it should move only in one direction, that is only in one direction, and after one round of armature, that is after completing of one round of armature like this, one round of armature, the coil falls into a slot to the right of the starting slot, that is after one round again it falls into the next. Suppose this is my coil starting here, it will move like this, again it will move, again it will move like this, again from this, again it will move like this, again from this it will move like this. So the coil is wounded only in one direction, wounded in one direction after completion of one round of armature. Suppose these are nothing but my commutator segments. These are nothing but what? My commutator segments, and I am starting my coil at this particular point like this. So my coil structure has been ended at this particular commutator segment. So after one round of armature, that is I have completed one round of armature here, the coil will falls into the another slot like this. Again in the next slot, again it will continue its winding. Again in the next slot, again it will continue its winding. So this is the representation of a progressive winding, where the coil can be wound only in one direction, and after completion of one round of armature, the coil will fall into the next starting slots. It will flow into the next starting slots, and in case of a progressive winding, it should be +1, that is it should move only in one direction, that is in case of a forward direction only. Now coming to the retrogressive winding. So it is completely opposite to the progressive winding. So what we have done in case of a progressive winding, the coil should be wound only in one direction, and after completion of one round of armature, the coil falls into the next, that is right of the next starting slot. So it is completely reverse here. The coil is wound in the opposite direction. The coil is wound in the opposite direction, and after one round of the armature, the coil falls into a slot to the left of its starting slot. Suppose, let me say that these are nothing but my commutator segments. They are nothing but my commutator segment. And let me say that I am starting a coil at this particular position like this. So it will move backward. It will move backward and again it will start. Again it will move backward, it will start. So it moves backward. That is the reason the value of YC is considered as what? It is considered as a -1 in this case. So if it is a progressive winding, it should move only in one direction, and after completion of one round of armature, it will fall right towards starting slot. In this case, it wound in opposite direction, and after completion of one round of armature, it will fall into the next slot which is left to the starting slot. So what is the main difference between these two things? If it is a progressive winding, you need to progress with respect to only in forward direction. If it is a retrogressive winding, you need to progress only in the left with respect to the starting start. Left with respect to the starting start. And coming to the applications. So what are there are different types of applications where the wave winding is used in case of a different DC machines, either it may be a generator or motor. So wave windings are generally used in small machines. Since in case of small machines, the current carrying capacity of armature conductors is not critical. That is, wave winding is generally used for what type of applications? It is used for small rating machine. It is used for what? It is used for small rating machine. Why it is used only for small rating machines? Because the current carrying capacity of the small rated machines is very less when compared to that of a large rating machines. Large rating machine. So this is regarding what is wave winding, how it is represented, and what are the different types of wave windings we have. How the progressive winding is reflected, and how the value of retrogressive winding is designed, and what are the applications of wave winding. Now we will move into the next important type of winding, that is lap winding. So what is the definition of a lap winding? Whatever it may be the number of poles, whatever it may be the flux, whatever it may be the different parameters which are offered by that particular machine, irrespective of all those parameters, always the armature parallel paths in case of that particular wave winding will be equal to what? 2. That is in case of what? In case of a wave winding. So in case of a lap winding, let us see the definition of lap winding. In lap winding, the armature coils are connected in series through the commutator segments in such a way that armature winding is divided into as many parallel paths as the number of poles of a machine. So I have taken an example there. I have taken a normal conductor. So if it is a wave winding, as it always the armature parallel paths are equal to 2, I have divided this conductor into 2 armature paths. But according to the definition of this particular lap winding, I can divide this armature winding into many parallel paths. It is not restricted to only 2 parallel paths as that of a wave winding, but that many parallel paths should depends upon the number of poles of a machine. Suppose if the number of poles of a machine is 4, this parallel path is divided into 4 like this. Suppose if the number of poles of the given machine is 6, this number of parallel paths should be divided into 6. If it is 8, it should be 8. If it is 10, it should be 10. So according to the design of this particular lap winding, the number of armature paths in case of a lap winding will always depends upon the number of poles. It is not restricted to 2 as that of a wave winding. That is the main advantage of having this particular lap winding here. So what is the definition of this particular lap winding? There is no need of having only 2 armature parallel paths. We can have many parallel paths in it, where the parallel paths depends upon the number of poles. That is, the value of A should be always equal to P. What is P here? Number of poles. And what is A here? Number of armature parallel paths. If in a given particular question the number of poles is 4 and he asked you to design the value of a lap winding, and he has given only one single conductor, now you need to divide this particular conductor into 4 parameters: Z by 4, Z by 4, Z by 4 and Z by 4 like this. If the poles is increased, you need to do same thing: Z by 8, Z by 8, Z by 8. So always the number of parallel paths in case of a lap winding depends upon the number of poles of a machine. If the number of poles is 2, the number of armature parallel paths will be 2. If it is 4, it will be 4. Coming to the design or structure representation of a lap winding here, you can see the structure representation here, where the commutator segment is divided into 3, 1, 2 and 3 here. There are 2 coils in it, where the coil 1 north pole and south pole representation of coil 1 and coil 2 is also represented here, where coil 1 is nothing but a conductor, coil 2 is nothing but a conductor. You can see the point is starting at particular point. The first in commutator segment 1, the coil 1 segment is starting like this, and it is moving through this, and it is moving to what? It is moving to the next commutator segment, and again it is starting, again it is moving to the next commutator segment. Again the same thing will be repeated like this. It will put to the next commutator segment, it will move to the next commutator segment, it will move to the next commutator segment. That depends upon the number of poles. That depends upon the number of poles. So whatever it may be, if the poles are 100, you need to design the same structure for number of parallel paths equal to 100. If it is 2, you need to design it for 2. If it is 4, you need to design it for 4. And you can see the starting end of the finishing end of one coil and also the starting end of another coil in this. Where the finishing end of one coil should be the starting end of the next coil. The same thing should be repeated depending upon the number of poles here. If the number of poles is 2, this diagram is correct. If it is 100, you need to repeat this particular diagram for 100 coils. 100 coils. So this is regarding what? So what is the main difference between lap winding and wave winding? Lap winding is nothing but always the number of parallel paths will be equal to number of poles of that particular given machine. If it is a wave winding, the number of parallel paths, whatever it may be, the number of poles, irrespective of given number of poles, always the number of parallel paths will be equal to 2. Coming to the explanation. Now, as that of the previous example, I have taken a single conductor Z here. As we know that it is a lap winding, the number of parallel paths completely depends upon the number of poles. And let me say that the number of poles of that given machine is nothing but some P. Some P or else it is nothing but what? Some 4. So how many number of parallel paths should I have for the given number of conductors here? It should have 4 parallel paths. That is the reason I have considered 4 parallel paths here like this. Some Z by P, Z by P, Z by P and Z by P. And what about the induced EMF here? The same thing whatever we have done in case of wave winding. The total generated EMF can be collected across the 4 parallel paths whichever collected here. So I have taken an example. If Z is the total number of armature conductors and P is the number of poles in the machine, then there will be P number of parallel paths in the winding and number of conductors in the parallel path here. Parallel paths here. So this is regarding what? This is regarding the lap winding. Lap winding. Similarly, the current will also get divided into each and every branch. As the number of parallel paths are 4, there will be 4 division of currents here. If it is Z by P, then it will be IA by P, IB by P, IC by P and ID by P. Coming to the next thing, different types of lap winding. So there are 2 types of lap windings here. One is simplex lap winding, another one is duplex lap winding. So as that of a wave winding, we have 2 types. One is progressive and retrogressive. Simplex and lap winding is also divided into 2 parts. One is simplex lap winding, another one is what? Duplex lap winding. Duplex lap winding. So the main difference between the simplex and also the duplex lap winding is nothing but what? Number of parallel paths which is observed between the brushes. So what is the main difference between the designing of a simplex lap winding and duplex lap winding or multiplex lap winding? The main difference between the two is the number of parallel paths which is observed between the brushes. So if it is a simplex lap winding, the number of parallel paths will be equal to what? It will be equal to number of poles. That is, the normal lap winding can also be considered as a simplex lap winding here. Why? Because we have come across the lap winding definition. Always the number of armature parallel paths will be equal to number of poles of a given machine. The same thing, the same design and same structure will be happen in case of a simplex lap winding also. Coming to the duplex winding, here the number of parallel paths is twice the number of parallel poles. That is, the value of A will be equal to 2 into P in case of a duplex lap winding. In case of a duplex lap winding, suppose if the number of poles is 4, that is P is 4. In general, if it is a simplex lap winding, there should be 4 parallel paths like this. Why? Because according to the definition of a lap winding, number of poles should be equal to number of armature parallel paths. But it is a type of lap winding which is considered as duplex lap winding. Duplex lap winding, where the value of armature parallel paths will be equal to what? 2 times of poles. So if P is 4, What is the number of armature parallel paths? It should be 8. That is, the given can be divided into 8 parts like this: 1, 2, 3, 4, 5, 6, 7, 8. So this is the main difference. That is, what is the number of parallel paths that is observed between the brushes that are connected in case of that particular machine. So in case of a simplex lap winding, always the number of parallel paths will be equal to number of poles. If it is a duplex lap winding, always the armature parallel paths will be equal to 2 times that of the poles that are connected in case of that particular machine. Now coming to the applications. So lap windings are generally used in case of a large rating machines. Large rating machines where the current carrying capacity is very high. So what are the applications of wave winding? It is used in a small rating machines. And what are the applications of a lap winding? It is used in a large rating machines where the current carrying capacity of that machine will be very high. And handling the currents is also very critical in case of a lap winding. So what are the different points we have discussed today? We have discussed about the different types of lap windings and also the different types of wave windings here. So what are the difference point? What is lap winding? In case of a lap winding, always the number of armature parallel paths will be equal to number of poles. In case of a wave winding, always the number of armature parallel will be equal to 2. What are the different types of lap windings we have? 2 types. One is nothing but what? Simplex lap winding. Another is nothing but what? Duplex lap winding. In case of progressive, it is wave winding, it is progressive, and another is nothing but what? Retrogressive. Progressive is nothing but what? Moving only in one forward direction, and always after completion of one rotation, it will move to the right of the next slot. If it is a retrogressive, it will always move in a reverse direction, and always it will move to the left of the starting position. If it is a simplex lap winding, always the number of armature parallel paths will be A equal to P. If it is a duplex lap winding, always number of parallel paths A will be equal to 2 into P. So these are the different types of armature windings that are used in case of a DC machine. If it is a generator, it is used to generate some amount of induced EMF as an output, and if it is a motor, it is used to generate or produce some amount of force or torque in the form of an output. So these are the 2 types of windings in general which can be used in case of a DC machine. In case of a DC machine, either it may be generator or it may be a motor. If it is a generator, the output will be what? The output will be EMF. If it is a motor, the output will be force or else the torque. So I am concluding this topic. What we have discussed about different types of armature windings in it. And in the next class, we will discuss about what is the output of a DC generator. That is, what is the EMF equation of a DC generator.
Like, share and subscribe. Hit the bell icon for more updates.